Many covalent compounds. Now it's time to study its properties. And secondly, we are going to learn something interesting about carbon, that is allotropy. Let's get started with the properties of covalent compounds. Now, there are four properties that we need to learn about the covalent compounds. The first one, they are usually found in the liquid or gaseous state, meaning they are available in the solid form, but not at room temperature. Room temperature, oxygen is a gas, alcohol is a liquid. But if you freeze them up, they will turn into liquid. Only some of the covalent compounds are found as solids. The second point, they have low melting and low boiling point, except diamond and graphite. Diamond and graphite are having high melting point and boiling point. But due to the weak molecular force of attraction, the attraction between the molecule is low. So you can easily break them up with a little amount of energy. Therefore, their melting point and boiling point is very, very low. The third property is they are generally insoluble in water, meaning they do not dissolve in water, but they are soluble in organic solvents. Whereas they are poor conductors of heat and electricity. This is because they do not contain ions, as they have shared electrons, and there is nothing positive and negative in these compounds. Now moving on to the occurrence of carbon. We learned that there are only 0.02% of carbon in the Earth's crust. Let us see how they are found. They are found in two types. The free type, free state, meaning they are only elemental form, or in the combined form, that is in the compound form. Now what is this free state? Free state, examples of free state are diamond, graphite, Buckminster fullerene. These are examples of carbon being in different forms but the same carbon. In the combined state, you know it, carbon dioxide. They are also found as carbonates, that is limestone, calcium carbonate. Also, fossil fuels, that is coal, petroleum, natural gas, are all examples of carbon compounds. So let's learn how and when did these carbon form different forms of itself. What is diamond? What is graphite? Allotropes of carbon. Basically, it is a property of an element to exist in various forms. The various physical forms in which an element can exist are called as allotropes of carbon. And this carbon has various allotropes. For example, graphite, diamond and fullerene. Graphite is on the left hand side, diamond above me, and fullerene is the one in the center. Why are they different if they are made up of the same carbon? The reason is they are not internally different. In fact, they are externally different. Meaning, graphite is internally different because of its structure. It contains carbon. Even diamond contains carbon, but they are internally different. Similarly, fullerene also contains carbon, but the structure is different. So how are the structures of diamond and graphite different? Let's distinguish between diamond and graphite. Diamond looks something like this, and graphite looks something like this. Now they are different in their structure. Colorless, transparent substance having extraordinary brilliance. Diamond shines and it has brilliant shine, whereas grayish-black opaque substance is what is graphite. Similarly, each carbon is linked with 4 different carbons in diamond, but in the case of graphite, it reduces to 3 carbons. So each carbon is linked to only 3 carbons. Because of that, it has a rigid 3-dimensional structure. But graphite is comparatively weak, and because of that, it has a sheet-like structure of hexagonal array. You can see hexagon-like structures everywhere. Array is a combination of these hexagon sheets. That is why it is called hexagonal array. The fourth point, does not conduct electricity because it does not have free electrons. On the other case, graphite conducts electricity because it has free electrons. Extremely hard and heavy is diamond. You cannot even break it with a hammer. In fact, the hammer will break and diamond will not. Graphite is soft and light as compared to diamond. That is why pencils can be easily written on the page. What are the uses of diamond and graphite? You know it. It is used as a precious stone in jewelry. Secondly, it is also used for cutting glass. Graphite is used in making electrodes. You might remember cathode and anode. So these are how cathodes and anodes look. Lubricants, that are substances used to remove or reduce friction between moving parts. The best example would be grease. So graphite has its own lubricant, and in lead pencils, which you've used since your childhood. The third allotrope of carbon is fullerene, and fullerene, my dear friends, is different from both of them. In fact, it is an allotrope of carbon containing a fixed amount of atoms, that is C60. So every molecule of fullerene will contain 60 atoms of carbon, and it's shaped like a football containing pentagons and hexagons. Who doesn't love that, right? It looked like a geodesic dome designed by a US architect called as Buckminster Fuller. Because it was designed by Buckminster Fuller, we say that this allotrope got its name as fullerene. Stay tuned to the next module.